Hi friends, today we are going to discuss the topic VSEPR theory and shape of covalent compounds for FYBSc chemistry student. Myself, Ramdas Suralkar, Assistant Professor, Department of Chemistry, Pratap College, Ambander. The content of this topic are VSEPR theory, what are the assumptions of VSEPR theory, what is the need of this theory, what are the applications and limitations of this VSEPR concept. Then we will see the examples of some molecules by applying VSEPR theory. SnCl2 molecule, then ammonia molecule, H2O, ClF3, SF4, BRF5, ICl2 minus and ICl4 minus complex. What is the introduction regarding this theory? So this theory was developed by Gillips and Newell in 1957 and the theory was extended by Sidgwick and Powell. This theory predicts the shape based on the repulsion between the electron pairs. Electron pairs form nothing but the bond pair and lone pair of electrons in the valence shell of the central atom. Each electron pair is stereochemically significant. What are the basic geometries according to VSEPR theory? 2 bond pairs means linear molecule and bond angle is 180. 3 bond pairs means planar triangle, bond angle is 120 degree. 4 bond pairs means tetrahedral geometry and the bond angle is 109 degree 28 minutes. 5 bond pairs, the geometry is expected geometry trigonal bipyramidal and the angles are 90 degree and 120 degree. For 6 bond pairs, the geometry of the expected geometry will be octahedral and all bond angles are 90 degree, and for 7 bond pairs the geometry of the molecule is pentagonal bipyramidal and the bond angles are 72 and 90 degree. What are the assumptions of VSEPR theory? So electron pairs, that is lone pair and bond pairs, collectively known as electron pairs, arrange as far apart as possible to minimize the repulsion. Lone pairs occupy more space than bond pair. So order of repulsion is lone pair or repulsion is greater than lone pair bond pair repulsion, and lone pair bond pair repulsion is greater than bond pair repulsion. So lone pair require more space and there is a repulsion between lone pair. So we get distorted geometry and bond angle. So increasing number of lone pairs decreases the bond angle and distortion in the molecule. What are the effect of lone pairs on the examples? Consider all the sp3 hybrid orbitals, sp3 hybridization in case of methane, ammonia and H2O. All they have sp3 hybridization, but there is difference in bond pairs and lone pair of electron. So in case of methane, CH4, 4 bond pairs are there. There is no lone pair, 0 lone pair, and the expected geometry is tetrahedral and the expected bond angle is 109 degree 28 minutes. So and actual also it is same because it has no lone pair interaction. Another example is ammonia molecule. In case of NH3 molecule, it has 3 bond pairs and 1 lone pair. So its expected geometry is tetrahedral, but actual geometry is pyramidal because of the presence of 1 lone pair of electron. So the expected bond angle is 109, but instead it is reduced to 107 degree 48 minutes. That is due to the repulsion between the lone pair and bond pair of electrons. In case of H2O molecule, there are 2 bond pairs and 2 lone pairs. So its expected geometry will be tetrahedral, but actually it is bent or V-shape due to repulsion, lone pair repulsive interaction. The shape of this molecule is bent or V-shape and the bond angle is reduced to 104 degree 27 minutes. That is less than the expected one because of the presence of 2 lone pair of electrons. Then we will see the application of this VSEPR theory to SnCl2 molecule. So in SnCl2 molecule, Sn is the central atom. It is surrounded by 2 chlorine atoms. So Sn belongs to group 14 elements. So it has 2 bond pair of electrons and 1 lone pair of electron. So expected hybridization is sp2 having 1 lone pair and 2 bond pair of electrons. So expected geometry Without lone pair will be trigonal planar and expected bond angle will be 120. But due to presence of lone pair of electron, there is a lone pair bond pair repulsion, and lone pair bond pair repulsion is greater than bond pair repulsion. That's why the bond angle get decreases and the structure also get distorted from trigonal planar to bent or V shape. So because of the repulsion between this lone pair and bond pair of electron, the molecule get distorted from this expected geometry of trigonal planar, and the actual geometry of this molecule is now bent or angular or V shape. Then we will see the next example of this VSEPR theory is ammonia molecule NH3. It is having 3 bond pairs and 1 lone pair. The hybridization of this molecule is sp3 and expected geometry is tetrahedral, and the expected bond angle is 109 degree 28 minutes. In this case also, because of the interaction of lone pair, the lone pair bond pair repulsion is greater than bond pair repulsion, and therefore HNH angle reduces from expected angle of 109 to 107 degree, and the geometry also, expected geometry is tetrahedral, but the actual molecule it is pyramidal because of the repulsion between this lone pair and bond pair of electrons. So the bond angle get reduced to 107 degree and the shape of this molecule is now pyramidal. Then another molecule we will see, H2O molecule. H2O molecule hybridization is sp3. It has 2 lone pairs of electron and 2 bond pairs of electron. So ideal tetrahedral angle is 109 degree and 28 minutes, but due to interaction of these 2 lone pairs with 2 bond pairs, the lone pair repulsion is greater than lone pair bond pair repulsion, and therefore the HOH bond angle get reduced from 109 to 104 degree and 104.5 degree, and the expected geometry for this molecule will be tetrahedral, but because of these 2 lone pairs of electron, there is a distortion in the geometry of this molecule, and the geometry of this molecule is now bent or V shape. So this is the angular molecule H2O having 2 lone pairs and 2 bond pairs of electrons. So in this way this molecule is V shape or bent. Another example we will see ClF3 molecule. So in case of ClF3 molecules, chlorine is the central atom and it is surrounded with 3 fluorine atoms. So chlorine belongs to group 17 element having 7 electrons in the valence shell. Out of these 7 electrons, 3 electrons are engaged in the bond formation and 4 electrons act as a lone pair of electron. So it has a 2 lone pair of electron and 3 bond pair of electron. So total electron pairs will be 5 pairs. So geometry will be, hybridization will be sp3d hybridization, and expected geometry will be trigonal bipyramidal. But due to presence of 2 lone pairs of electron which require more space, so these lone pairs occupy the equatorial position on the trigonal plane. So this out of these 3 positions at the 3 corners of the equatorial triangle, 2 positions are occupied by the lone pairs and 1 position for the fluorine atom, and the axial positions are occupied by the 2 fluorine atoms. So because this due to equatorial position of these lone pairs, the bond angle between this lone pair will be 120 degree. Otherwise, if we occupy these lone pairs at axial position, then there is a repulsion between electron pairs and bond pairs. So that's why the preferable position for this lone pair will be equatorial position, and the fluorine occupy axial position. So expected geometry of this molecule is trigonal bipyramidal, but because of the repulsion between this electron pair, lone pair electron, this fluorine atom get distorted from this ideal shape, and their bond angle, expected bond angle between these 2 axial fluorine will be 180, but due to repulsion and more space requirement of these electron pairs, so the angle get reduced from 180 to 175, and the actual shape of this molecule is now bent T shape. So it is a bent T shape molecule, and the FClF bond angle is now 87 degree instead of 90 degree. So actual it should be a 90 degree, but because of this repulsion between lone pair and bond pairs, this fluorine get distorted toward this fluorine and bond angle get reduces from 90 to 87.6 degree. Another example is SF4 molecule. So in SF4 molecule, central atom is the sulfur atom. So sulfur atom belongs to group 16 element having 6 electron in the valence shell. Out of 6 electron, 4 electrons engage in the bond formation, and the remaining 2 electrons, they act as a lone pair of electrons. So it has 4 bond pairs and 1 lone pair. So total electron pairs will be 5, and so the expected hybridization is sp3d. So, and the expected geometry for this molecule will be trigonal bipyramidal. So this lone pair occupy the equatorial position, because at equatorial position the distance between the 3 electron pairs is 120 degree. So that's why this lone pair occupy the equatorial position of the trigonal plane, and the remaining 4 positions are occupied by the fluorine atom. So out of these 5 electron pairs, 3 pairs at the equatorial and 2 at the axial position. Out of these 3 equatorial position, 2 occupied by the fluorine atoms and 1 occupied by the lone pair, and remaining axial position occupied by the fluorine atom. So the expected bond angles in this molecule are 90, 180 and 120. But because of the repulsion between lone pair and bond pair, this bond angle get reduces, and now the bond angles are reduced. That is, instead of 90, it is 89 in between this. Instead of 120, the bond angle is 118 and instead of 180 degree, the bond angle is reduces to 177 degree. So the molecule, the geometry of this molecule is seesaw, or it is called as folded square. Another example is BRF5 molecule. In case of BRF5 molecule, bromine belongs to group 17 element. It has 7 electrons in the valence shell. Out of these 7 electrons, 5 electrons are engaged in the bond formation with 5 fluorine atoms, and 2 electrons that are remaining act as a lone pair of electron. So it has a 1 lone pair of electron and 5 bond pair of electron. So total electron pairs are 6 electron pairs. So it requires sp3d2 hybridization for 6 hybrid orbitals. So expected geometry of this molecule will be octahedral, but due to the presence of 1 lone pair. Now in case of octahedral geometry, 4 positions occupied at the 4 corners of a square planar, and 2 positions are occupied at the axial position of the perpendicular to this square plane. So out of these 4 fluorine atom occupy at the 4 square planar corner of the square planar complex, and the 5th fluorine atom occupy axial position, and the 6th lone pair of electron also occupy the axial position. So this molecule, geometry of this molecule is now square pyramidal, because it can forms the one pyramid only about this square. So it is called square pyramidal. Otherwise this molecule, if instead of lone pair, if it is a bond pair of electron, then it will have octahedral geometry. But because of the presence of lone pair of electron, this molecule actual geometry is square pyramidal, and the hybridization is sp3d2. Another example of application of VSEPR theory is ICl2-. So in case of ICl2-, iodine is the central atom. So in iodine there are 7 valence electron and 1 negative charge, so total 8 electrons. So out of this 8 electrons, 2 electrons are engaged in the 2 bond formations, and the 6 electrons, they act as a 3 lone pair of electrons. So total electron pairs are 5 electron pairs, and therefore the hybridization of this molecule is sp3d. Now in case of sp3d hybridization, there are 3 equatorial position and 2 are axial position. So 3 equatorial position at the 3 corner of the trigonal plane, and 2 axial position are perpendicular to this trigonal plane. So there are 3 lone pair of electrons, so this lone pair occupy the equatorial position of the trigonal plane, because the more space is there in at the equatorial positions. They are 120 far apart from one another, and at axial position 2 chlorine atom occupy the axial position. So the this molecule actually its geometry should be trigonal bipyramidal, but actual shape of this molecule is linear. So it is a linear molecule with an bond angle between Cl I and Cl is 180 degree. Another example of application of VSEPR theory is ICl4 minus. So again, iodine has 8 electrons in the valence shell, 7 of this iodine and one negative charge, so 8 electrons. Out of this 8 electrons, 4 electrons engage in the bond formation with 4 chlorine atoms, and the remaining 4 electrons act as a 2 lone pair of electrons. So total electron pairs are 6, 4 bond pairs and 2 lone pairs. So 6 electron pair require 6 orbitals, therefore hybridization will be sp3d2, and the expected geometry of this molecule will be octahedral. So out of octahedral geometry means 4 positions should occupy at the equatorial of the square plane, and 2 positions are axial position which are perpendicular to this square plane. So now we have 2 lone pairs and 4 bond pairs. So these 4 bond pairs occupy the 4 corner of the square plane, and the 2 axial position which are occupied by the 2 lone pairs, because they are far apart from one another. These 2 lone pairs are 180 from one another, and the remaining chlorine iodine chlorine bond angle is 90 degree. So so the actual shape of this molecule is square planar. So this is the end of this valence shell electron pair repulsion theory. You should understand this topic. Thank you.